Hello students, welcome to Educat. In the last video, we have discussed about the electrolytic cell. Now, we will discuss about the product of electrolysis. That is, when electricity passes through the solution, then what's the chemical reaction will take place. And finally, what will be the product during that process, we will discuss in this topic. First of all is electrolysis of NaCl. First point here is electrolysis of NaCl, molten NaCl. How's that? We have studied here. When you will study by yourself, then you will find out that there is no systematic way. But now I tell you about the systematic way. Let's see. First of all, electrolysis of NaCl. Okay? Or molten NaCl. Electrolysis of molten NaCl. There is two portions in that electrolysis. One is molten NaCl or fused NaCl. Second one is electrolysis of aqueous NaCl. Okay, molten NaCl means NaCl will exist in liquid phase. So what happened here? In the solutions of NaCl, there will be only Na plus and Cl minus. There will be no water in that. What happened here? That's you connect here through this one. In the solution, there is Na plus and Cl minus. Okay. So what happened here? There is here negative charge here. So Na plus will get attracted towards this rod, NaCl. Okay, but this electrode we usually of inert. That means noble metals we take. Platinum, palladium and nickel. Platinum, palladium and nickel. They are called noble metals. Noble metals. When we will take the noble metals, they will act as a source of electron or a sink of electron. That means here negative charge here added. So if we take a platinum rod, here also platinum rod. So what happened here? Electron through this one, through the cell, electron will come here. So here this platinum rod has acted as source of electron. So here the platinum rod will act as source of electron, because through this battery the electron will come to this electrode. Then after what happened here, Na plus will get attracted towards this platinum rod. So reaction at here anode is here, here cation is coming, so cathode it is. Where the cation will get deposited, that will be called cathode. So what happened here? Na plus, which is in aqueous state, that will gain one electron and convert it to sodium atom, which will deposit at this rod, and it will act. Exist in solid phase. Okay. So reaction at cathode is that much, and what will be reaction at anode? Reaction at anode. What will be there? Listen here. So Cl minus will get attracted towards this platinum foil. So this Cl minus, and it will lose one electron. The extra electron here that will be lost. So that become here chlorine atom and one electron. The two chlorine atom will combine together and form Cl2. Okay, or you may write here half Cl2 here also. So what is here in the examination, that is either IIT main examination or in NEET examination, usually the question asks about the product of product of electrolysis. Okay, so overall reaction, what is here? Product of electricity will be, what will be? Product of electrolysis. Product of electrolysis will be here sodium and Cl2. So sodium and Cl2. Very easy, because there is here molten NaCl, so there will be only sodium and chloride ion inside the solution. So only sodium ion will get attracted towards the cathode and the chloride ion will attract towards the anode. At cathode there will be gain of electron and at anode there will be loss of electron. Okay, so let's see here. Now we proceed. Next one point will be about the electrolysis of molten aqueous NaCl. That is electrolysis of aqueous NaCl. Okay, electrolysis of aqueous NaCl. Here given here, one is about the molten NaCl, another one will be also about the aqueous NaCl. So what happened here in aqueous when we do the electrolysis of aqueous NaCl? So inside the solution, here same, at cathode there will be sodium and at anode here cathode, both platinum or any noble metals we will take, here negative, here positive. So inside the solution there will be Na plus, because NaCl which you will take, that will dissociate into Na plus and Cl minus. So there will be inside the solution there will be Na plus and Cl minus. Water will also dissociate there. There will be some amount of H plus and OH minus. Okay, so now here is two cation, Na plus and H plus. The Na plus has been obtained after the dissociation of NaCl, and H plus has been obtained by the dissociation of water. That means you know already water, in water the concentration of H plus ion is 10 raised to power minus 7, and when any electrolyte added to the water, then the concentration of H plus ion as well as OH minus ion increases tremendously. So what happened here? Reaction at cathode. So there is two cation here. In this case there is two cation, that is Na plus and Cl minus. So Na plus will get attracted or H plus will get attracted. So that's we will have to decide by a standard electrode potential. Na plus will get attracted towards the cation or towards the cathode, or the H plus will get attracted towards the cathode, or the Na plus will get attracted. That we will have to decide by a standard electrode potential. You know the standard electrode potential of hydrogen is 0 and that of sodium is minus 2.71. A standard electrode potential of hydrogen is 0 and that of Na plus, that means sodium, is minus 2.71. Electrode potential means reduction potential. That means the H plus ion have greater tendency to gain the electron compared to Na plus. A standard electrode potential means reduction potential. That means the tendency to gain the electron. So H here among Na plus and H plus, the H plus ion will have greater tendency to gain the electron. So at cathode, the H plus ion will get attracted. This H plus ion will get attracted towards the cathode. So this H plus ion will gain electron and convert it to hydrogen atom. The two hydrogen atom will combine together and form H2. And then after here, and an ion is Cl minus and OH minus. So now a standard electrode potential of Cl minus is 1.36 volt and that of water is 1.23. The standard electrode potential of Cl minus is 1.36 and that of water is 1.23. But here it indicates that the water will have greater tendency to get oxidized. Here a standard electrode potential is lower. So water will have greater tendency to get oxidized, but the oxygen will get deposit due to over potential of oxygen. You already know that oxygen has over potential. So due to the over potential of oxygen, the OH minus ion will get attracted towards this anode and not the Cl minus due to over potential of oxygen. Actually, the Cl minus, if we will consider about the standard electrode potential, then we will find out the standard electrode potential of here water is less than that of Cl minus. So water should get attracted, but due to the over potential of oxygen, the OH minus due to the over potential of oxygen, the OH minus, what I told here. So water should get attracted, here guys, due to the over potential here, Cl minus will go here. Water should go on the anode, but due to the over potential of oxygen, the water will not form, the Cl2 will form. So reaction at anode, in that case, due to over potential of O2, the O2 will not form. Okay, so what will happen? The Cl minus, that will lose the electron, convert into here, that will lose the electron and convert it to Cl2. So half mole of Cl2 will form. So product of electrolysis will be hydrogen at cathode and Cl2 at anode. Okay, in the examination usually question asks what the product of electrolysis, and for IIT main examination question may ask during the electrolysis of molten NaCl, why Cl2 forms, not the oxygen. So here, due to the over potential of oxygen don't form at anode. Okay guys, next point will be, next one, let's start the electrolysis of water. Okay guys, first of all, you think by yourself and tell water is a good conductor of electrolysis. Water is a good conductor of electricity or bad conductor of electrolysis. Sorry. water is good conductor of electricity or the bad conductor of electricity? That's you think. Just I give you 1 minute. Think about that. Now guys, listen. Water is a bad conductor of electricity. The pure water is a bad conductor of electricity. Why? Because the water, in case of pure water, the concentration of H plus ion and OH minus ion is 10 raised to power minus 7. And this value is quite less. This value is quite less. So, here amount of this H plus and OH minus ion is not enough for the conduction of electricity. When any electrolyte will be added in pure water, then water will become good conductor of electricity. The water in our day-to-day life, people think that it is good conductor of electricity, because if anyone will touch the electric switches by the wetted hand, then that there is conduction of electricity and the person experience the jerk of electricity. So water is good conductor of electricity. That is the myth. That is not. Actually, what is that? The water we have get wetted. So the water in our day-to-day life used by us are actually not pure water. That is solution. I am not telling that it is harmful or beneficial. Pure means if only that substance is, and impure means if anything get added, that will be beneficial for human health or harmful for human health. That doesn't matter. Impure substance means if any other substance is also present in that substance. So, pure water is bad conductor of electricity. So, when we will have to do electrolysis of water, then a small amount of electrolyte will be added to make the water good conductor of electricity. So, during the electrolysis of water, a small amount of electrolyte are added to make the water good conductor of electricity. Keep this one in your mind. Pure water is bad conductor of electricity. So, during the electrolysis, a small amount of electrolyte are added to make the water good conductor of electricity. So, a small amount of water we will add there, and what will be there? How's the there will be electrolysis. So, what happen? Suppose here cathode, here anode, what happen here? H plus and OH minus. Water, there will be H plus and OH minus ion in water, and we have added a small amount of electrolyte. So what happened here? At cathode, here is negative charge, here negative electron is coming to this rod. So H plus will get attracted towards this rod. So at cathode, what happened? H plus will gain 1 electron and convert it to half H2. Then after at anode, water will get attracted. So at anode, OH minus ion will lose the electron, convert it to OH, and the two OH combine together. The two OH will combine together, and as a result, there will be formation of H2O and half O2. So, when we will do the electrolysis of water, at cathode, the hydrogen gas will produce and at anode the oxygen gas will produce. So product of electrolysis will be product of electrolysis. That will be H2 at cathode and O2 at anode. Okay guys, very easy it is here. So that was about the electrolysis of water. Nothing else here, water is the only. So H plus will get attract towards the cathode and OH minus ion will get attract towards the anode. No any problem here. Then after this, electrolysis of sulfuric acid. Let's see here. Okay, not given here. So let's see about the electrolysis of sulfuric acid. Sulfuric acid, H plus, SO4, 2 minus, 2 moles of H plus, like that. You know already, H2SO4, Hall dissociate, H2SO4, that dissociates into, gives 2 moles of H plus, and SO4, 2 minus. So here this one, here. So for cathode, no any difficulty at cathode. What will be there? H plus will gain the electron and convert into H2. At anode, what happened? The SO4 2 minus, that will lose the electron. That will lose the electron. SO4 2 minus will lose the electron, and some of the SO4 2 minus. Okay, SO4 2 minus suddenly lose the electron. This SO4 will combine with another SO4 2 minus molecule. There is SO4 here, and that compound will be highly unstable. So that will get combined with another SO4 2 minus, and there will be formation of 2 moles of here 2 sulfur. So S2 so here S2O4 and 2 negative charge. So this one, this S2O4, that is here. So S2O4 2 minus will form there. You recall that guys, H2S2O4. Yeah. Oh, 8 here. Sorry guys, here both get combined. So here 8. So S2O8 2 minus. H2S2O7, that is called oleum, and H2S2O8, that is called peroxo disulfuric acid. Peroxo disulfuric acid. In India and in the UK, the spelling of sulfuric acid is SULPHURIC, and in US the spelling of sulfuric acid here is on the place of pH, that will be F. So when you will read the books of which published in US, if you will read the chemistry book of US, then you will find out that sulfuric acid will be written as SULFURIC. Okay, sulfuric acid will be like that. So don't bother about that. So during the electrolysis of water, the product of electrolysis of sulfuric acid will be hydrogen at cathode and peroxo disulfurate ion. That will be okay, and this one here will again combine with hydrogen and form H2S2O8. So peroxo disulfuric acid will be the product. So product of electrolysis of concentrated H2SO4. Product of electrolysis of concentrated H2SO4 will be hydrogen at cathode and peroxodisulfuric acid at anode. Okay guys, that was about the electrolysis. Now we will discuss about some questions of this related to this topic. First of all, if a current of 0.5 ampere flows through a metallic wire of 2 hours, then how many electrons would flow through the wire? Okay, this question is quite easy. This question 2.10 is quite easy, but asked in the IIT main examination, as well as there is probability of asking this question in 12th board examination also. And this question has asked in NEET examination. So this question usually for the IIT main examination usually don't ask. As I have seen, this question has not asked in IIT main examination. Once there was the formation of IIT main and IIT advanced on the place of NEET exam, AIEEE. Nowadays the examination of AIEEE don't help, but here there be some examinations for the engineering at state level. So for the state level engineering examination, this question is relevant, quite relevant, and for NEET examination it's relevant, and for 12th board examination also. So I am discussing here. How much current is flowing? 0.5 ampere. And question is asking how much for 2 hours the current has been flowing of 0.5 ampere. And it is asking how much electron is passing through that. Okay, so just goes on the stepwise. 0.5 ampere current. So what is here current? Here it will be in ampere when charge will be in coulomb and time will be in charge in coulomb and time in second. So 2 are here, so time you will have to convert into second. So 2 into 60 into 60, that much second. Okay, and that means here, so how much charge is passing through that? So charge is passing is 0.5 into 2 into 60 into 60, that much coulomb. Why coulomb? Because current here is ampere is actually coulomb, charge in coulomb, that upon time in second. So here that into time, when you have coulomb into time, upon time, so that will be coulomb. So charge here this much, so this will cancel out. That much coulomb charge has been passing through the solution. That much through a wire, that much coulomb charge has been passed. That means 3600 coulomb of charge is passing through the electron in 2 hours. Now, charge on electron is how much? Charge on electron is 1.6 into 10 to the power minus 19 coulomb. So, when charge will be 1.6 into 10 to the power minus 19 coulomb, then number of electron will be 1. When charge will be 1, so same here till here, when charge will be 1, then number of electron will be 1 upon 1.6 into 10 to the power minus 19 coulomb here. Now, when charge is 3600 coulomb, so number of electron will be 3600 upon 1.6 into 10 to the power minus 19. So this 10 to the power minus 19 will go in the numerator, that become 10 to the power 19. So 3600, this decimal you take out, so 10 also into 10 to the power 19, that upon 16. In the examination, what will do? 16 to the 32, carry 4, and then after that means 2 here near about, and 10 to the power 19 here, that was, and 3 zeros is also 30 also. So 19 and 3, 22. So that will be 2.2 into 10 power 22. So number of electron near about. Whatever is the option near goes on the firstly. Watch out the power. What's the power? 10 over 22. So in which option there will be 10 raised to the power 22? Click on that option. And if more than in one more than one option, if in more than one option there is 10 to the power 22, then whose value will be near about to 2.2. Click on that. Okay. And for the board examination, you will have to solve. So as I have solved like that, you will have to also solve. Then after is 2.11, suggest a list of metals that are extracted electrolytically. You will have to form a list which can be extracted electrolytically. So goes on the table of your NCERT book, goes on the table, and in that table whose standard electrode potential will be positive, like copper, silver, gold, and so on. That can be like here, come here, hydrogen here. So above to that one is this one here, a standard electrode potential of like this one, AgBr is positive, AgCl is positive. That means silver you can extract electrolytically, copper you can extract, then after iron you can extract, silver like this one, manganese you can extract, or like this one. So these are the metals which can be extracted electrolytically. That means the metals whose standard electrode potential is positive. A number of metals there is whose standard electrode potential is positive, that can be extracted electrolytically. Okay. So now just proceeds on the next question, next topic. Now watch out the next question. Consider the reaction this one. This question is very important. 2.12. This question was asked in 12th board examination. There is a reactions, and what is the quantity of electricity in coulombs needed to reduce 1 mole of this one. In the examination of main, IIT main, and in NEET examination, here 6 electron has been given. So that will not ask. That will be not given. And in 12th board examination, that will be given, and very easy this question is to solve. Listen, when you will not, if 6 electron has not been given in the examination, what will be there? Cr2O7 2 minus here, that is here reducing with 2, reacting with 14H plus, that gives 2 moles of Cr3 plus and 7 moles of H2O. Balance the equation here. So oxidation number of chromium here is how much? 7. Chromium, suppose X, there is 2 chromium, so 2X plus 7 into minus 2, that will be equal to minus 2. Here oxidation number of chromium is plus 6. Here this one. So 1 chromium from plus 6 to plus 3. The oxidation number of chromium has changed from plus 6 to plus 3. That means 1 chromium has gained 3 electrons. Plus 6 to plus 3. So change in oxidation number is 3. So 1 chromium has gained 3 electrons. So there is 2 chromium. So 2 chromium will gain 6 electrons. So that's why here it is 6. Which will be not given, which will not give in the IIT main examination or in NEET examination. This value will not give in IIT main and NEET examination. That value of electron you will have to calculate like this one. What's the oxidation number? Here. So how much change in oxidation number? Oxidation number has been decreased. So through how much oxidation number has decreased, that much electron has gained by 1 atom. There is 2 atoms of chromium, So 2 chromium will gain 6 electron. So that's why what's the quantity of electricity? So what happened here? There will be 6 Faraday of electricity will require 6 Faraday of electricity will require to reduce them 1 mole of Cr2O7. So 6 Faraday of electricity. 6 Faraday of electricity means 6 into 6 Faraday of electricity means 6 into 96,500 coulomb. So 6 into 6 Faraday of electricity, 6 Faraday or 6 into 96,500 coulomb or 96,483, whatever you would like. That much coulomb of charge will require to produce 1 mole of Cr2O7 2 minus. Okay guys, very easy question here. So in this video we have discussed about the product of electrolysis. That is, when electricity will pass through the solution, then water will produce at cathode and anode. When we have taken molten NaCl, there was formation of Na plus at cathode and chlorine at anode. In case of NaCl, in case of aqueous NaCl, the product of electrolysis will be hydrogen at cathode and chlorine at anode. Third point was here, when we have electrolyzed the water. So during the electrolysis of water, hydrogen gas was produced at cathode and oxygen gas at anode. When we have electrolyzed the concentrated H2SO4, then there was formation of hydrogen at cathode and the oleum at anode. Oleum means H2O8. Oh sorry, not oleum, there was formation of peroxodisulfuric acid at anode. Okay, and we have solved these questions here. These questions, out of these 3, the 2 question was highly important for the IIT main examination as well as for 12th board examination and the NEET examination. So this we have discussed. In the next class we will discuss about the batteries and few more important questions which is important for IIT 12th board examination as well as for NEET and IIT main examination. Okay guys, it's all for today class. Thank you, Team Educate.